Let's now talk about how to add, subtract, and divide radicals. So first things first, let's talk about adding and subtracting radicals. So two or more radical expressions have this that have the same indices, so same index, and have the same radicands are called like radicals. And we can combine them in the exact same way that we can combine like terms. Right? So notice, if you have 4x plus 6x, how would you add those? You just add them, right? So that's 10x. So in the exact same way, if you have 4 square root of 3 plus 6 square root of 3, right? That's just 10 square root of 3. But also, right, how would you add 4x plus 6x squared? You can't, right? These aren't like terms, so you can't combine them. So in the exact same way, if you have 4 square root of 2 plus 6 square root of 3, you can't combine them. It's the exact same thing. So just kind of think of them as the like terms. So example number 1. We have 7 square root of 2 plus 8 square root of 2. So same indices, right? So the square roots, under them is 2, square root of 2, so we can just combine them. So 7 plus 8 is 15, so this is just 15 square root of 2. Done. Next, we have cube root of 3 minus 4x cube root of 5, cube root of 5 minus 4x cube root of 5 plus 8 cube root of 5. So we can just add all the coefficients. So the coefficients of the first one is 1, right? So this is the same as 1 minus 4x plus 8 times the cube root of 5. Another way you can think about this is if we could factor out a cube root of 5 every time. So essentially that's what's happening when you do 4x plus 6x. Essentially what's happening is you factor out the x, and then you're adding it. So you were factoring this whole time, didn't even realize it. So going back to our problem, so that's a side problem. Going back to our problem, right? We can still combine because you can do 1 plus 8. So we get 9 minus 4x times the cube root of 5. And since you can't combine the 9 and the 4x, right? You can't, this is not 5x because this is a constant with no x. This is the x. So this is the answer. Can't combine anymore. Part C. So we get 8 times the 6th root of 5x minus 5 times the 6th root of 5x plus 4 times the cube root of 5x. So notice all of them, all of the numbers under it, right? All the radicands are 5x, totally good, except all the indices are not the same, right? We have indices of 6 and 6 and 3. Which means that these are the only two that we can combine. We cannot combine the cube root. So for this one, we get 8 minus 5, which is just 3. So we get 3 times the 6th root of 5x minus 4 times the cube root of 5x. And that's it. We can't simplify anymore. Last one of this section. So we have negative 2 times the cube root of 3x plus 7 times the 4th root of 3x plus the cube root of 3x. So again, 3x is the radicand for all of them. Awesome. However, we have indices of 3, 4, and 3. So these are the only two that we can combine. So negative 2, remember this is a positive 1 out front. So negative 2 plus 1 is negative 1. So negative cube root of 3x plus 7 4th root of 3x. And that's it. Yeah. If you want to put negative 1, that's fine. But again, we always assume a 1's in front, so you can just put the negative. All right, let's look at some harder stuff. So let's try to, what can you do if you have something like this? So obviously, we do have square roots, which is great, but there's an 18 and an 8. So, can we simplify this square root of 18 and the square root of 8 to where we would actually end up with the same radicand underneath? Well, let's see. So 18 is 9 and 2, and then 9 is 3 and 3. So since the square root, we need a group of 2 numbers. So this 3 can come out. So we see that we get 7 times 3, and then we have a 2 underneath, square root of 2. 7 times 3 is 21, so this is 21 times the square root of 2. All right, if we get 5 square root of 8, so 8 breaks up into 4 and 2, and then 2 and 2. So square root means you need a group of 2 numbers. So here's one group of 2 numbers, so a 2 can come out. So we get 2 times 5 times square root of 2 on the inside. 5 times 2 is 10, square root of 2. So we are adding these numbers. So this simplifies to 21 square root of 2 plus 10 square root of 2. And now, square root of 2, square root of 2, those are the same. So we can just add the numbers out front. So 21 plus 10 is 31 square root of 2. And that's our final answer. Part B. 3 square root of 20 plus 5 square root of 45. So can't combine them yet, but let's see if we can simplify. So 20 can be 4 and 5, 2 and 2. Square root means you need groups of 2. So here's one group of 2. So 2 times 3, and then square root of 5 is going to be still on the inside, or 5 is going to be on the inside. So this is 6 square root of 5. And then for the other one, 45, that breaks up into 9 and 5, 3 and 3. So group of 2 numbers comes out. So we get 3 times 5, and then we have 5 on the inside. So 15 square root of 5, and we're adding these 2 numbers. So now we have square root of 5 and square root of 5, so we can combine. So 6 plus 15 is 21 square root of 5, and we're done. Part C. So 4 square root of 27x minus 8 square root of 12x. So x can't simplify anymore. 27 is 9 and 3, 3 and 3. We can take out this group of 2 3s. So 3 times 4 times square root of 3. 3 times 4 is 12. So this is 12 square root of 3. Square root of 12. So that's 4 and 3, 2 and 2. 2's can come out. So we have negative 8 times 2 times the square root of 3. Negative 8 times 2 is negative 16 square root of 3. Now we have square root of 3 and square root of 3, so we can subtract. So 12 minus 16 is negative 4. So our final answer is negative 4 square root of 3. X. Sorry. Yeah, we should still have that x inside. There we go. All right, part D. So 12, we already said that's 4 and 3, 2 and 2. So we can take out that 2. So 2 times 3 times the square root of 3x is 6 square root of 3x. And then 27, 9 and 3, 3 and 3. 3's come out, so we get negative 6 times 3 square root of 3x. Negative 6 times 3 is negative 18. Since we have the same radical expressions now, we can subtract. So 6 minus 18 is negative 12. So the full answer is negative 12 square root of 3x. Last problem like this, and then we'll move on to dividing. So 7 square root of 3 minus 2 square root of 5. So 3 can't be broken up anymore. 5 can't be broken up anymore. So that's the answer. Done. Can't simplify anymore. Can't combine them. All right. When dividing radical expressions. So if you have the nth root of a over the nth root of b, right? You can just combine that to one root. So 1 nth root of a over b. And you can go in the opposite direction as well. So example number 3. So let's simplify. So square root over square root. So we can make that one square root. So square root of 48x cubed over 6x. 48 divided by 6 is 8. X cubed divided by x to the first. You can subtract. So 3 minus 1 is x squared. 8 can be broken up into 4 and 2, 2 and 2. So this group of 2 can come out. And then, of course, we have x squared. So there's 2 of them. So 1x can come out. So we get 2 times x times the square root of 2. Or you might like it written like this, 2 square root of 2x. Either way. Part B. All right, so this is a little trickier because there's a 2 out front. So you need to make sure that that 2 stays out front. And it's square root of 4x, or 45xy over 5, right? So we've combined them. However, if right now, if it's not under, if a radical, sorry, if this number is not under a fraction, it means it's over a fraction. But here it was under a fraction. So we need to actually remember that out front is a 1, so this should be 1/2 out front, not 2. Okay, so I'll just go through that again. So essentially, out front here is a 1/2. So when we combine the radical to one radical, we need to make sure that 1/2 is out front, not 2. That's going to be a common mistake. 2 is not out front. All right. Now, when we divide 45 by 5, we see that we just get square root of 9xy. Square root of 9 is just 3, because you can break that into 3 and 3. So we get 1/2 times 3 times the square root of xy. Or 3/2 times the square root of xy. So that's our final answer. Part C. Square root. We can just combine them all. So we get 40x to the 5th over 2x. 40 divided by 2 is 20. X to the 5th divided by x to the 1st, we just subtract. So that's going to be x to the 4th. 20 can be broken up into 5 and 4, 2 and 2. So a 2 comes out. We can break up this x to the 4th into 2 groups of 2, right? So essentially what happens is you can just do x to the 4 divided by 2 to get x squared, right? And then we have square root of 5 back on the inside. So if that didn't make any sense, we can show you, right? So this means there are 4 x's, so x times x times x times x. So one group of x's can come out, another group of x's can come out. So essentially, since this index is a 2, we can just do 4 divided by 2, which is x squared. Because x times x is x squared. Good. Final answer. Part D. So again, notice out front, it's not 5, it's 1/5, right? So make sure we have 1/5 before we combine square roots. So we get 50xy over 2. 50 divided by 2 is 25. Square root of 25 is 5, because that's just 5 and 5, right? So we get 1/5 times 5 times the square root of xy. These 5's cancel because one's on the top, one's on the bottom. So the answer is just the square root of xy. Part E. All right, so notice, x's can't simplify, 25 can't simplify, y squared can't simplify, right? Within the fraction. So we can actually do the opposite this time. So we can take, the square root of x squared over the square root of 25y to the 6th. We can kind of think of it like that as well. So again, we have x squared. So since there's a 2 out front, right, we just divide that by 2, so 1x can come out. And again, if you think about it, x squared, x, so 1x comes out. So we have an x on top. Square root of 25 is just 5, so 5 comes out. And then if we have y to the 6th, and it's the square root, right, then that's just the same as 6 divided by 2, which is y cubed. And again, if you want to see that, there's 6 y's multiplied together. So there would be 3 groups of 2. So this is where we would get y cubed. And that's our final answer. All right, let's look at this one. So we get the square root of 9x cubed y to the 10th. So since nothing can simplify inside, we can just kind of think of it as separating them. So the square root of 9 is 3, because that's just 3 and 3. Let's look at the bottom. So the square root of y to the 10th, that's just y of 10 divided by 2, which is y to the 5th, is going to be on the bottom. And again, if you add 10 y's, 2, 3, 4, 5, 6, 7, 8, 9, 10, you would have 5 groups of 2. Right. So this one creates a y, that creates a y, 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 y. So you just have y to the 5th on the outside. And then you get on the x on the top. So we have the square root of x cubed. So that's the same as x to the 3 halves. So if you want to think about that, if we think about it as a remainder, that would be x to the 1st with a remainder of 1, right? So essentially what that would be is x to the 1st times the square root of x. And again, if that doesn't make sense, that's totally okay. You can just write it out. X, one group of x's comes out, and then you're left with an x square root of x. And there we go. Final answer. All right. Once again, if this is confusing, make sure to email me or text me. Otherwise, as always, have a great day.